How are you? My name's Taggart, Bowe-Gaddy. I've been a JavaScript developer for about 10 years now, and I have been dealing with the date API for all of those years, so I was very excited to be able to give this talk. Before we get started, how many of you have used the date API in JavaScript? And how many of you have found it to be totally intuitive and handles every case you need? There you go. So luckily, they are rolling out a new API, and that's what we're here to talk about today. So how did we get here? Started with sundials. And I know that it's a little bit of a cop-out to do the since the beginning of history thing, but that's where we're starting, because at this point in time, you didn't really need a whole lot of context about what the sun was doing on the other side of the world. You needed to know where in your day things landed. That's still relevant today. You know, what time, if I ask you what time it is, you're not going to tell me what time it is in Beijing and then give me an offset to calculate what time it is here. You're not going to tell me that we're in daylight savings time, so you subtracted an hour from some other internal process you have. You're just going to tell me what time it is. That's what they used to do. And then once we started expanding our worldview and we added calendars, that was a new paradigm where we're now accounting for not just what time it is today, but the concept of tomorrow and the day after, and maybe days an arbitrary amount of time in the past. And then politics got involved, and we eventually got time zones and daylight savings time, which is a lot more political than I think is within the realm of this talk. But it's worth noting that the time zone offset is not really a realistic line of thinking about how we're calculating that offset in a geopolitical space. And then after that, we immediately go to JavaScript. I'm obviously skipping a few steps, but this is what's relevant here. JavaScript, which was notoriously written in 10 days by Brendan Eich, based its datetime API off of Java's datetime API. Java's was then entirely rewritten 2 years later, and we still have the same one 26 years later. Obviously, we're skipping some steps, but so let's talk about what that API that Brendan Eich wrote actually does. Its main purpose is to convert ISO 8601, which is an international standard for measuring time along a singular timeline, from the beginning of time until the end of time, and not infinitely, but within reasonable bounds for the computers we have today. We'll refer to that as Unix time in this talk. That's how you might have heard it referred to. You might have also heard it referred to as epoch time. But either way, it's just we're counting milliseconds since a certain point of time and behind a certain point of time, and it's very linear. What our date API does is it converts it to a different international standard called UTC, which is in itself a synthesis of a couple other standards, TAI and UT2. But what Unix time does, that linear idea of having a standard second, which is 1/8,000 or 86,400th of a day, it converts that into a standardized definition of something that's a little more human. And that's where we get the integration of the calendar and the sundial time, which is more commonly known as wall clock time, because we use wall clocks, not sundials. And accounting for 24 time zone offsets. Note what's missing here is it does not account for the geopolitics of actual time zones. It just accounts for offsets. And really quickly, I'm sure if you're familiar with what I've already talked about, you're familiar with this, but it's worth noting that what date does is it places, or what really UTC and Unix time do, but date represents it, is it places 0 Unix time directly at midnight on January 1st of 1970 within Greenwich Mean Time, or UTC 0, or Zulu time. Again, it's all political, but if you ask someone who's in England, they're going to tell you it's Greenwich Mean Time. So what date doesn't do is it does not account for time zones or daylight savings time in a standardized way. It's worth noting, in a standardized way, because a lot of browsers have been starting to integrate time zones. They've, when you ask the browser, hey, what time is it now? It will tell you whatever your system's time is and say you're in Eastern Standard Time, Eastern Daylight Time, but it's not doing a whole lot with that. It's more just spitting it out at you. And different browsers spit it out at you in different ways, and other browsers won't do it at all. But what it does do in a standardized way is account for what offset you're in. So if I ask you, what time is it right now? UTC would tell me 3:46 minus 5. It's in Zulu time, it would be 8:46. But what we're doing here is basically the spec doesn't account for it. It just leaves it up to the browser, and you end up with some really weird edge cases, a lot of arithmetic that crosses over daylight savings time events, for example. It's calculated inconsistently across browsers. And we'll see how they standardize that here. Another thing it doesn't do is it doesn't allow for calculations of date or times absent of one another. It doesn't allow you to uncouple those concepts. I can't ask the date API, what is the difference in time between 4 o'clock and 5 o'clock? I have to ask it, what's the difference in time between 4 o'clock and 5 o'clock in Eastern Standard Time, or in offset -5 on a specific day. And that just means that if anyone's ever tried to do this type of arithmetic, it means you're mentally holding the load as the developer of what's relevant in your date object and what's not. And another thing it does is it does not provide immutability. And the example I was just talking about earlier, where let's say you want to calculate time independently of date or vice versa, or represent a full day, you can't just do that with a singular date object. I can't say, hey, when is ConnectTech? I can't tell you, or when's day 1 of ConnectTech? I can't tell you it's November 8th. I would have to tell you it's November 8th at midnight, which people often do. And what I would have to do to accomplish that with the date object is I would have to create an object for a specific day, which would then default to the system time to fill the time field. And then I would have to mutate that object to put it at 0 time, which again is just a very opaque way of managing date times that put a lot of the load on the developer. It doesn't help you. The abstraction is more of a barrier than it is a way to help you. So I'm sure if you've ever tried to do any of the things we just discussed, you ended up defaulting to one of these packages. Some of the popular ones are Moment.js, which was king for a long time and has recently been replaced, or not recently, it was actually a little bit ago, was replaced by Luxon. That's the same set of developers. And then pretty much immediately after that, the date function library, which is a bunch of utility functions for native date objects, came out. And honestly, a lot of the stuff we're talking about that's frustrating, date function does a great job of just abstracting it away from you. The mental load that I was talking about that you're responsible for, date function picks up that mental load. It's great. But it doesn't really do the time zone database like Moment or Luxon does. And then there's Day.js, which is just a really minified, it's very tiny. And I see a couple of y'all writing, hopefully at the end of the talk, this slide will be entirely irrelevant because luckily we are getting a brand new date API directly into JavaScript. It is currently a stage 3 proposal. That's stage 3 out of 4, although there's also a stage 0, so it's really out of 5. But either way, stage 3 basically means the broad strokes are very solidified. They have a first pass at an API, and they've published it, and they've released a polyfill that allows you to play with it. And they're currently accepting feedback. The organization is TC39. So if you see anything today and you think, I think I know a better way to do that, now's the time to email them and share your thoughts, and maybe it'll be part of the stage 4 proposal. Once it gets past stage 4, the browsers usually start implementing it during stage 4. And then once it's officially part of ECMAScript, the browsers will all finish up implementing the spec, and that's where we are. So we are currently in a place where we can play with it, which we'll be doing today. So what Temporal does is it's, first off, no longer limited by UTC. It extends UTC. They go into it in details in their release documents and their documentation. And they got rid of mutability. Every single object is totally immutable. Whenever you do any operation, it spits out a new object. That's kind of a more in vogue way to write JavaScript these days rather than passing mutable objects around. So it's just going to line up with a lot more of modern paradigms. And perhaps one of the biggest things that it does is it integrates IANA time zone database, which is the time zones we're all used to seeing when you sign up for a new service or you boot up your computer for the first time and it says, where in the world are you? It doesn't have Atlanta, Georgia, but it does have New York, and you have the sense to say, oh yeah, I'm in the same time zone as New York, that's me. And it has them for all over the world, and what this does differently than offsets is it accounts for that geopolitical factor. We'll see an example later. Phoenix doesn't account for daylight savings time, but the rest of the region does. So if you tell Temporal, hey, I'm in Phoenix versus, or the Phoenix region versus the Dallas region or Denver region, then you might get different times depending on what time of the year it is. It adds support for non-Gregorian calendars. I personally haven't run into this, but I mean, I live in a pretty Western-centric, world. I'm sure for people that don't deal with Gregorian calendars or have a need to calculate something in a different calendar system, this is huge for them. It also provides objects for non-coupled time and date objects. So it allows you to do what we were talking about earlier. Do abstract calculations for dates, point to or for times, or to point to abstract dates. So I can just refer to a day. I can refer to a month and a day. I can refer to a day and a time. It's really pretty great. And yeah, plain time is the wall clock time, which has been one of the biggest complaints of people for a long time, that date didn't have a way to represent that. Now we do. We're going to come back and look at this. You don't need to memorize it now. We're about to go play with all of these objects. But this is kind of, this is their object model, where we see kind of the fully composed version of all of these kind of smaller constructs is a zoned date time, which is a date, a time, and a time zone. That allows you to describe where you are in the world, where you are in the calendar, and where you are in the day. That basically lines up with an instant, which is really what we were talking about when we were talking about the first date API, is it maps instance, a certain point in time, to a human representation on the globe of that instant. So really, the date API was just that far left exact time types blob. The new objects, the new hotness is everything else, and we're going to be playing mostly with everything else. So I'm open to questions, and then I'm just going to jump into it and start playing with it and show you some examples. But are there any questions before I jump into the code? Like time relative to another time? Yes, so durations are kind of account. So if you have a line, you have a line chart, you can represent an instant as a point in time, or you can represent a duration, which would be fill a block of that timeline. You can also, as we'll see closer to the end, do what's called balancing, and that actually uses the keyword relative to, which means when you're doing some kind of abstract calculation between durations and points, so instance and durations, if it needs to have more context to complete that calculation, you can tell it what point in time it's relative to. So let's say, for example, I'm trying to calculate the relative time between February 10th and March 10th. And I want to know, hey, what's the relative time here? It's not going to be able to do that unless it knows what year we're in because of leap years. So you can pass a relative to and let it know this is the context we're working in. Now give me this duration. Does that answer your question? Okay, cool. Cool. Anything else? Cool. Let's play with it. On the temporal or the TC39 website, where you can see the docs, it actually has the polyfill just loaded right here into the browser. So if you want to play with this right now, just go to tc39.es/proposaltemporal/docs, and you can play along with it right here with me. So we can see some of these are everything that we just saw in this object model. Right here on the temporal object, we've got calendars, durations, instants, now, which is pretty, that's going to feel pretty familiar coming from the date API. And then you've got all of these abstract plain objects, which are not context aware of time zone or offset. And then you've got zoned date time, which is the culmination, a time zone plus some combination of plain objects. So let's go ahead and create an instant. If I say const now equals temporal.now.instant, we get an object. It has inside of it a representation, which is what we would see if we call now.toString or toJSON. And we'll talk about the strings later. You might notice it looks a little different from time, but it has a lot of the same information. We have basically everything you need to know what time is it now. We can ask it, and it's getting now from the system time. If we want to create some of these plain objects, we're just going to create them here from the now object, but we'll see other ways to create them. If we want to create a plain date in ISO time, which is really shorthand for the Gregorian calendar, we could also say plain date, then pass a calendar-like, which means a string, an actual calendar object, an object, or a tuple that says calendar : and then your string. But either way, we're just going to say plain date ISO. So now we have a plain date object. If in our regular date API, if we were to create a date object and then ask it what time it was, it would tell us the time. It would either be midnight if we were to set it manually, or it would be whatever time it was when it was created, which is the default. For this one, if we ask, hey, what hour of the day is this plain date object? It's just undefined. It doesn't have that. It doesn't have any concept of hours. It just has a day. So if we ask it what day it is, it'll tell us it's the 9th, but not hours. So let's move on. We're going to see the same thing with time. If I create this time object and I say, hey, what day is it? Undefined. If I say what hour is it, it'll give us an hour. A date time is obviously going to combine the two, and we can just create that manually using plain date time. There's these APIs everywhere, and that's going to be about what you expect. We'll have hour, and we'll have day. You can also combine them. So we have our plain day object. We have our plain time object. If we want to now create a date time from the two of them, go ahead and put them together. We're going to create a plain date time. We're going to create it from this date, and then use this, this concatenation method called with plain time to combine it. And then we got it right here. And it has the time, and it has the date. So it's pretty cool. You can also use the from method to actually just pass it an object with all of your relevant data. So with the date API, you would have had to pass in a perfectly constructed string and tell it to parse that string to get your year and your date and your month. No more of that. We're just passing it an object that says year 2020, month 10, create a year month. Those are your keys. Go ahead and do it. And we've got it. Yes? They're zero-based. Yeah, so, I mean, they're zero-based. Nope, they're one-based. Sorry. Yep. Yes, yeah, they're more human. Sorry, I should have known that. And then also, it does give you things like it'll tell you the number of days in the month. Like, it really is there to be kind of a human tool. One thing we'll talk about at the end is it doesn't have the humanized functions, though, that like Moment has. Like, I can't calculate, like, I can't get one day ago, you know, but I can get days in a month, though, and it'll give me 31. That's not zero-based. Cool. So now let's talk about zoned objects. When we start giving these plain objects some context about what time zone we're in, we can make more specific a plain object. We can take a plain object like our plain date time, and then we can add a time zone to it. We can say in America/New York. And then it will know, and it adds it at the end here. So you'll note it does have the offset. It includes that information, but it also tells you the information about how it got that offset. Which key in the IANA database did it use to figure out what is the time zone offset for this day for this place? And this is a newer, we'll talk about strings in a second, but the brackets are new. That's not something we've seen in JavaScript before with dates. So as an example that we were talking about earlier, where two places in the same region might have different offsets, let's look at July 4th, which is in the summer, which is subject to daylight savings time. So if we create a plain date time from July 4th, 2020, which was a leap year, which I guess isn't actually relevant here. We'll talk about leap years in a second. Then we can take that plain date object, which has no concept of where in the world it is. We're talking abstractly about July 4th here. Now we want to talk about July 4th in Denver. We can say, hey, why is it, oh, does toString not? Oh, thank you. Okay. Yes. So again, immutable. But if we convert it to a date time, then it will set it into a -6 offset. If we do it in Phoenix, which does not observe daylight savings time, we'll get it in a -7 offset. So it's just asking the database, hey, what's the offset for this place in this time? If we were to do the same exact thing for November 8th, we would get the same offset because they're outside of daylight savings time, and they would have synced back up. So let's look at the time zone object. Also, feel free to cut me off. I'm just kind of barreling through these, but yeah. Any of the, I'm sorry, can you repeat that? Yeah, the browsers are all going to implement this independently. Oh, backend, yeah. So if it has a system time, it will use that, but otherwise, I think it all works pretty independently. Like it's all, yeah, I mean, it'll work. I think Node will intend to implement this. This is part of ECMAScript. What exactly is it? Oh, what the time frame is? I don't think we know that yet. In fact, I know for a fact we don't know that yet because it's a nebulous soon. I think once it gets to stage 4, we'll see things like Babel, like transpilers are going to get this first. Like they're going to go ahead and jam it right in there, so you'll be able to transpile with this. And then the browsers will do it on their own time, and Node will also do it. Yes, it's a different string format, though, than date. Yeah.
Just thinking through this, so the time zone data actually gets updated every now and then. And today, we as application developers bundle, are responsible for downloading the latest version whenever we want and bundling it with our app. It's nice if the browser does it for us, but at the same time, we become at the mercy of the browser. So a user with an older version visits a site and sees outdated values and some date picker. Are there any considerations about handling that?
I think the consideration is if we're at the will of IANA and the world's political leaders, then I think we have to be at the will of the browsers to implement updates for this. Mm-hmm. Gotcha. So are you wondering if you can override the browser? Right. I think that's just a design decision in a realistic situation. There might be a way. I don't know. I haven't seen anything about being able to pass in your own database. I mean, it's weird because you can pass in your own calendars. You can make your own calendar. Like it has all the presets for Gregorian and, all of the other various calendars, but you can still create your own and tell it, hey, here's the calendar object to use. So I wouldn't be surprised if there's a way. I haven't seen anything about it. Oh, yeah, I guess you can just create your own time zone in theory. Easy data. Yeah. Yeah. They released the spec, and you can go ahead and call the time zone superclass and make your own time zone. So yeah, if you want to, when you boot up your application, say like wipe away all of the browser's time zone objects and pass in your own. Yes. Yeah. I think most developers are excited about not having to think about it, though. Cool. And speaking of, let's jump into what this looks like. So if we call let's create a time zone, and we're just going to create it from a string. And again, this takes a time zone-like object, or it takes an item. The typing is weird. It's really odd. They tried to do kind of typing, but it's not like TypeScript or like type-safe typing, but there's all of these these different object types. Usually you can just use a string, an object with kind of a sensible key name pair, or an actual object, itself. But for now, we'll just use a string. So let's create this time zone. And there's really not much to it other than telling you which time zone it is here. I'm sure we could dig into the actual representation, but what we can do with it is then we can create an instance from that time zone. So we can go in a lot of different directions. Like we saw earlier, you can start with like an abstract time and then add a time zone to it to get an instant. You can also create a time zone and then pass it an abstract time and get an instant from that. So let's create an instant where we'll say TZ1, which is New York, and get the instant for my birthday in January 2021. And then we get an instant object from that, which is just a point in time. We can also get like the ISO or the Unix time from that. It's not locale string. That's the more human readable one. But either way, we can do the same exact thing. Let's do it for Cairo. We create a time zone for Cairo, and then we ask it, hey, which instant was midnight on my birthday in Cairo? And that's just a slightly different time. And then if we want to compare them, this is where we start getting tricky. So we can say, what's the time from our first instant until our second instant? We have 2 points on a line. What's the distance between them in hours? And we see that I turned 31 7 hours before I would have turned 31 7 hours earlier if I were in New York than if I were in Cairo. So we'll talk about durations in a second. I really quickly wanted to show you this new string, just because we've seen it a few times now, but we'll do more duration stuff in a moment. So this is what the new string looks like. And if we break that down, it looks like this. This is also not just a good way to understand the new string, but another maybe more intuitive way for some people to understand the new object model. It's an extension of ISO 8601, and two of the main things we're doing, other than kind of shifting a little bit of there's an RFC to update ISO 8601 to look like the green box, which is why it's clarified with RFC 3339. Because this is not what the ISO 8601 representation looks like in our browsers today. But if we look at it, at the beginning, we have our year month, and then we have our month day, and that together is a date. You know, when someone asks you, hey, what's the date? You give them a year, a month, and a day. That's what you got there. You got a time, which is in 24 hours within the day, and then you have an instant, which accounts for an offset along with that time. And then you can sugar that with zone data, which really is just telling the computer, how did we get this instant? Like, what was the information we used to put together exactly what instant in time this 4 o'clock was? And that's with these two brackets. Sorry, it got cut off a little bit. There is a closing bracket on the calendar extension. But it's using brackets within the date time string. That's not really in like most date ISOs. That's not like a standard thing, but JavaScript is doing it anyway. So that's what our string looks like. And if we want to look at what the date string looked like before. It was this more human readable representation, which I guess is great. But obviously, when I want to just like do some abstract, 4 o'clock minus 3 o'clock math, I don't want to have to know how to parse out this whole date time string or type it all out to get it to parse. And obviously, you can pass in less data, and some browsers do that great. Some browsers don't need most of the data we have in here inside this date, but that is the official date string, and it's just a mess trying to get your string to parse. So you can still parse from this string, like I could say temporal dot zone date time dot from, and then give it a string, and it will create an object from it. So it can still parse it. It's just not as necessary. I personally hope to never have to parse a date time string ever again. In fact, they call it, I think they actually call it the persistence model. Like it's not something that's intended to be used day to day. It's more for persisting a date time outside of the JavaScript environment. Cool. So let's do some quick duration math. So we have a pure year month that we created earlier, right at the beginning. It was October of 2020. Now let's create a December of 2020. So we have 2 year months. They're a couple months apart. We can run until on that. We saw until work on a much smaller time frame earlier. Sorry, I was wrong. And we get 11 months, so I guess I should probably do since. Negative 11 months, I guess. This is what I wanted to do. There we go, yeah. Why is it not 2 months? That's odd. Did I change? I did change PYM. Sorry about that. So the math is right. I just forgot that I had changed the PYM object while we were playing with it. So we get this, this duration object, and the duration object thank you. Allows us to say, hey, how many months is this? We get 11 months. We can also do that on the order of seconds. Let's create one then, and let's create one now. And we'll talk about rounding in just a moment so we can see how to go from one to the other. And if we do A since B, we'll get, and it's this kind of complex string representation, but you can also break it down if we were to do, it was about 5 seconds between the time it took me to create 1 to 2. So we have this until and since objects, which are really great for dealing with 2 points in time. We can also use add and subtract for kind of more arithmetic style. Like if we just want to like add an abstract duration rather than calculating between 2 points in time, we have a point in time and we want to add a duration to it. We can use add and subtract for that. So if we create an instant for now and add 5 hours, we'll get later tonight, 11 o'clock or so, 2:19. And then it works in the opposite direction. We can create a duration from a specific number of hours and then pass in that duration object. So if you had like a pure object rather than just passing like, in the moment I want to add 5 hours, but we have some calculated duration and then we want to subtract take an instant and subtract a duration object from it. That works just fine as well. Oh yeah, we'll talk about rounding in a moment. Also, a really cool thing that it does with not just these arithmetic objects, it also gives you a comparator. So if you've never used a comparator before, you pass it two objects, and it returns to you -1, 0, or 1. That means object A is less than object B, object A and B are equal, or object A is greater than object B. That works fine on its own, but where it's really useful is you can pass a comparator to sort. So let's create a few abstract days. And then create an array of them. So if we have our array of Veterans Day, President's Day, Memorial, we call sort on them. Then we can pass the comparator to sort, but we need to make sure that we call the correct comparator. So these are all plain dates, so we need to pass the comparator for plain date. So we call temporal.plainDate.compare. That's the comparator, and then I'm just calling join to make it more human readable. And then it sorts all of our date objects correctly. That's really cool. I mean, if we wanted to call the compare object directly, we could also do that, and we could call Veterans Day, President's Day, and we would get 1, so Veterans A is greater than B. Cool. Before I get into the concept of balancing, are there any other questions before we move on to kind of our last topic? I don't know, but I did see someone comparing this to Java, and I've honestly never worked in Java, so I don't know. I don't have an answer for you. I do know that when actually the bracket discussion, people were talking about Java assuming the same standards, so it seems like there's at least some people are interested in that. Yeah. No, not that. I have a slide at the end about that's kind of one of the main things that's lacking here. People are basically ideating that because that will be a much smaller library and much easier and just reduced scope, everyone's kind of expecting that to just show up, like someone's going to write it almost definitely because this doesn't do it. That's one of the main things that Moment did that this doesn't. So I don't think temporal is ever going to, it seems outside of the scope of temporal, but it seems like it would be really not terribly difficult for someone to release a package for temporal that does that. Yeah, so it does take much more. So let's say let's take a plain date, Memorial Day. So if we want to zone this, you'll see that it does not take a string, it takes what it calls an item. So I could actually pass a time, like I have a time zone object from earlier, for what was TZ1, America, New York. I can pass an actual time zone object and it'll work fine. I can also pass an object that says time zone, America, New York. And that'll work as well. So it takes kind of, those are the three main things that it does. In the documentation, you'll see it'll say like time zone like. So it doesn't take a time zone, it doesn't take a string, it takes anything that identifies what time zone it should be using. I honestly, the calendar stuff, I kind of skipped over because I felt like it was just not like something that most of us would be using, but let's take a glance. I don't really know. Let's see. Where's the string? Okay, it looks like it's an ISO 8601 standard. So they just, the generic standard has that as a way to identify a calendar, so they went ahead and used it. Cool. Yes, sure. No, which is, I don't think so. There is the to locale, but no, that still doesn't use any human readable. No, I don't think so. Especially because, like, I mean, different languages spell it differently. Like, May is M-A-I in a bunch of European languages. So I think they just went with the day. You pass it the calendar. You let it know that, we're using the Gregorian calendar, and I think it's kind of up to you to then map 1 to January. Yeah. Cool, so let's talk briefly about a concept that they call balancing, which is pretty important. It's kind of one of the last, it's the trickier part. It's the harder thing to wrap your mind around from what we've talked about here. So they use the term balancing to basically describe resolving an arbitrary situation. That could mean a lot of things. They refer to rounding as balancing. So if you have 90 seconds, they differentiate that from 1 minute and 30 seconds. So if you want to make something less arbitrary, you can balance it. You could also have 1 minute and 90 seconds. That's totally valid within this framework. But then if you balance it, that would be resolving it down to 2 minutes and 30 seconds or 180 seconds. Sorry, I'm awful at arithmetic. But either way, rounding durations is something they call balancing, but that's kind of the easiest of the balancing. The others are specifically with daylight savings time. There's a lot of balancing that has to be done then, especially doing arithmetic that lands on or crosses over daylight savings events, even in potential situations. So we'll look at a couple examples of that in just a moment. Or when you're adding context or specificity, you might have to give it some details. So if you're moving from a plain date time to a zoned date time, but your plain date time, let's say your plain date time is February 29th, and then you try to zone that to a year that, or add it to a year month for a year that doesn't have leap days, you would need to balance that. You would need to either put it on February 28th or May 1st. So they give you a bunch of tools for balancing, for handling ambiguity. So let's look at some examples of that. First, let's look at rounding. That's one of the easier ones. So exactly the situation we just mentioned. Let's say we have a duration of 90 seconds, and we want to round it to be 1 minute and 30 seconds. We call the round function, and then we tell it what we want the largest unit to be. So if we want it to be in hours, you probably wouldn't want to do that, but you could. You could get 0 hours, and I guess it would still be 1 minute and 90 seconds. Unless you truncate it, you can also do that. We'll look at that in a second. But either way, in this situation, we want to go from 90 seconds to 1 minute and 30 seconds. You tell it, hey, your largest unit should be minutes. It does that, and then we get 1 minute and 30 seconds. And if we wanted to look at minutes 1 and seconds 30. We can also tell it to make the smallest unit minutes, which would actually round it up to 2 minutes because it doesn't have a concept of seconds anymore. The smallest thing it can deal with is minutes. Let's say we don't want to round up, we want to round down no matter what. And the default is that 30 seconds is right on the edge. I chose the edge case. So 30 seconds it goes up, below 30 seconds it goes down. If we want to force it to always go down, we can say, hey, your rounding mode is floor. And it goes down to 1 minute. If we want to make sure that it always goes up, we can say ceil. And it will always go up to 2 minutes. We can also parse this like duration string code that always starts with PT, and then 2M, 30S. We can parse from that string representation if we want, so we can make a 1 minute and 30 second duration from that string, and then there it is, 1 minute, 30 seconds, and then we can round that to, it's 1 minute, 30 seconds. Let's say we want the largest unit to be seconds. We want it to say 90 seconds. We just call dir2.round with the largest unit being seconds. There we go, 90 seconds. There are a few other options, but those are kind of the main two. Is going to be largest unit, smallest unit, and your rounding mode. But check out the documentation for the others. They're probably less common, but they're there. The next form of balancing is using a key when you round called relative to. So let's create a duration of 370 days, so over 1 year, right? Now we want to round that to account for years. We don't want to just know how many days. We want to know how many years, it's going to be 1, and how many days. Well, if we do that, oh no, we have a range error. And it says the starting point is required for years balancing. So it needs to know how many days are in this year. Sometimes we have 365, sometimes we have 366. Leap years are a thing. So if we pass it a year, and we say 2019, not a leap year, we pass using this relative to key. And it will say 1 year and 5 days. If we do it on a leap year, 1 fewer day in the next year because 1 extra day of your 370 was used up by the first year. So it'll be 1 year and 4 days. So this is where context matters. And if context matters, it'll let you know usually. Or in the next situation, there is a default for some situations, but you can also tell it exactly how you want to handle it. Before I jump into the last one, are there any questions about rounding, either using relative to or just the regular rounding API? Cool. So the last situation is called disambiguation. So let's create an unambiguous time. There's no confusion about what time this is. We're creating a time from, from November 1st at 1:30 in Los Angeles. No ambiguity about that. We know what time that is. If we all of a sudden strip it of its zoning data, it becomes... Oh, sorry, I changed the name. I think I have a couple typos in the gist that I'm going to link you to, so I'll change that really quickly. So now all of a sudden, if we look at this time, it's ambiguous. That could be 1:30 anywhere in the world. That could be 1:30 in Bangalore. That could be 1:30 in Shanghai. That could be 1:30 in LA. We really don't know. If we now try to zone it, though, also, this is a leap year. Oh my goodness. Yep, I changed the name. Oh, sorry, y'all. How do I select all of them? Oh. All right, so if I try to add context to my ambiguous calculation, it works, but you'll notice it's slightly different. It is 1:30 a.m. minus 7, when the object we started with was 1:30 a.m. minus 8. Does anyone want to guess why? It's an event we all just experienced in its wonderful glory. We were asleep for it, probably. Daylight savings time. So we gained an extra hour. There are 2 1:30 a.m.s on November 1st in Los Angeles. So we started with one of them, and then we went unambiguous, and then we removed any data about where we were in the world, and then when we added it back, the computer just had to guess which 1:30 we were talking about. So we can tell it what to use. So the first situation is using compatible, which is what it uses by default, which is, oh, forgive me if I get this wrong. When you're gaining an hour, it goes to the earlier one. When you're losing an hour, it goes to the latest possible thing. And there's a reverse situation where instead of having 2 times, you have no times, so it could be one of 2 things. So when you have 2 options, it goes to the later one. When a single time could be 2 different things, it could be like 1:30, it could be 12:30, or it could be 2:30, it will go to the earlier one. Or you can just straight up tell it. You can say, hey, if this is ambiguous, I want you to choose the earlier option. I'll use 7 minus 7. If you tell it to use the later one, it'll use minus 8. And you can also just tell it to straight up reject it. Just say, hey, if I'm ever accidentally doing a situation that's ambiguous and I'm trying to set a time, just throw a range error. And there we go, multiple instants found. So that's how disambiguation works. But by default, it will just kind of handle it for you. And like a lot of the time, it's not that big of a deal. But if it is an ambiguous situation that you have a specific way you want it handled, you can tell it which method to use. And there's other situations. We are out of time. But balancing does have a few other situations where you would use these same tools. But it's all the same tools. And it's just tricky, weird situations. But that is the temporal API. I do have one last slide, sorry. So what does it not do? We already talked about the humanization functions or the localization functions. It's not going to make human readable strings for you, sorry. Another thing it doesn't do is it doesn't handle leap seconds. If you want an existential crisis, the Earth is slowing down, sorry. It's mostly due to tidal friction, rotational energy getting turned into heat from waves. And when do leap seconds get applied? Kind of arbitrarily by a weird international group that just says, hey, next year we're going to have an extra second. So it doesn't handle it. Your system time handles it. And your computer just asks, how long is a second today? And your computer tells the browser. So thanks for coming to my talk.